Finally, we're going to talk about horizontal stretches and shrinks. This is the one transformation that we did not discuss last time in lesson 1.2. So a horizontal shrink is going to cause the graph to narrow. It's moving toward the y-axis, which means it's moving away from the x-axis. We still have A representing our number, but now notice that A is inside. It's not outside of our f of x, it's right there inside with x because it's horizontal. And so our shrink that we talk about with horizontal is going to actually be the opposite of what you see inside the equation. Remember that when we're horizontal, we are inside with x and we are opposite. So the opposite of multiplying by a is dividing by a, or multiplying by its reciprocal. Horizontal stretches, on the other hand, are going to widen our graph and move away from the y-axis. We still are notating it with an A on the inside, right there with x. It's only affecting x. And our stretch is the reciprocal, the opposite. That 1 over a value will be larger than 1. So the very important thing to remember here is as soon as you see an equation with a number on the inside right in front of x, you need to, in your head, flip it over and do the reciprocal. The number appears as the opposite in the equation as what the actual transformation is, just like our shifts to the left and right. Let's go ahead and look at our quick reference guide and take a closer look at this. All right, so as we said, our horizontal stretches and shrinks, let's talk about shrink first because that's what we talked about in the notes. Our shrink has an A value on the inside. Here you're seeing what it looks like in absolute value bars, but again, it could be parentheses, some sort of grouping symbol. And so we actually have, in this case, a shrink by 1 over A, which is our reciprocal. 1 over A. So if we wanted to state what was happening here in this particular graph of absolute value of 3x, remember that the 3 is our A, but our actual shrink is a shrink by the reciprocal, by 1/3. So whatever you see in the equation and the actual thing that's happening is a reciprocal. This is 1 over A. It's a shrink by 1/3 when you see a 3. Let's look at horizontal stretches. Those work the same way. So a horizontal stretch still has an A, and it is describing a stretch by the reciprocal, a stretch by 1 over A. So again, we are dealing with the reciprocal, the opposite, because we are horizontal and inside. HIO, horizontal, inside, opposite. And so in this case, our 1 over A value, our reciprocal, is going to be bigger than 1 because we are stretching. So if we wanted to describe a stretch by 3 in our equation, that is going to show up as 1/3. Our A value is 1/3. Our A over 1 value is 3, and that is what we put in our statement. Let's go ahead and look at a couple more examples. I want to make sure that this one is clear to you because this one can be a little bit confusing. So let's go ahead and take a look at example 6. We are starting with our absolute value function, and we want to horizontal shrink it by 1/3. So remember, immediately that 1/3 is our reciprocal, 1 over A. So we are going to be substituting 3A into our equation. Let's first start by writing our rule. So g of x, remember horizontal things happen inside with x, so we are going to say that this is f of 3x, not f of 1/3 x. You have to say the reciprocal, our actual a value. So in this case, since we are starting with the absolute value parent function, we have the absolute value of 3x. So remember, the description is 1 over a, the equation is a. All right, one more example. Let's go ahead and look at a horizontal stretch by 4. 4, again, is 1 over a. So 1/4 is going to be the a that we state in our equation, in our function. So g of x is equal to f of 1/4 x. And substituting in for our specific absolute value equation here, we get absolute value of 1/4 x. Go ahead and rewind this video and watch parts of it again until you can make sure that you have the relationship between a and its reciprocal 1 over a straight in your head.